My name is Ana Fernandez, and I'm going to present the study titled The Effects of Irradiance on Sexual Maturation of Diploid All Females in RAS. Sorry, my voice is not good today. This study was performed by the Bioled company in collaboration with the IMED, the Institute of Marine Environmental Technology of the University of Maryland. But before talking about the study, I would like to introduce the company. Bioled is a Chilean company specializing in artificial lighting for photoperiod. We provide submersible lights, an automated photoperiod system, and light sensors. Currently, Bioled holds around 50% of the Chilean market, and we also provide our products and services to different companies in different areas in the world. The R&D department is an important area of the company. We develop a research project in order to improve our knowledge in aquaculture and thereby providing to our customers with an accurate advice according to their objectives. And this study is an example of our effort to achieve these goals. And going directly to the study, as many of you know, the early maturation in Atlantic salmon has a huge impact in RAS system. This illustration of a typical productive cycle doesn't work. We can recognize a risk period between 1.5 to 2 kilos, but we have observed early maturation before than that in fish as small 80 grams. The consequences of early maturation are indirect and direct losses, causing a decrease in growth potential and product quality. The early maturation in salmon is a highly plastic process, and there are many factors involved. Two of the most important are photoperiod and water temperature. Regarding photoperiod, there are two key aspects. One is the light regime, which involves the light and dark hours to which the fish is exposed. And secondly, the lighting characteristic. It means the spectrum and irradiance. All these factors should be considered for an optimal photoperiod management. And going into more details, the spectrum is based on the salmon sensitivity to specific wavelengths. And in that case, salmon is more sensitive to the blue and green end of the spectrum. And regarding the irradiance, there are several studies that have demonstrated the optimal values of irradiance for vision and prevention of early maturation. In that case, we don't talk about looks. We talk about irradiance. That is different. Why not looks? Because looks is based on the human eye sensitivity. So not necessarily reflects how the fish perceive the light. For this reason, we talk about irradiance. All this knowledge laid the foundation for the use of artificial lighting for reducing early maturation. For example, in Chile, with the use of artificial lighting, the maturation rates are less than 2%. But what about the relation between photoperiod and early maturation in RAS? We know that is different. For example, in this review of Christopher Good, he showed the red square, different maturation rates in different facilities with different temperatures, salinities, and photoperiod regime. So what is important here are the high rates of early maturation under different environmental conditions. In another study in which all diploid females were evaluated, the author showed or observed high maturation rates in those groups, highlighting the complexity of managing maturation in land-based systems. So, in order to improve our knowledge of the factors involved in photoperiod and the control of early maturation, we began to question the effect of the irradiance on early maturation in RAS. As background study, background information, in this study, the author observed that high irradiance promotes early maturation compared with the low irradiance in 100-gram fish. So we aimed to test different irradiance levels with large fish based on the hypothesis that it would improve control over early maturation. So we conducted a control study to more precisely fine-tune the effect of the irradiance on maturation in fish over 1 kilo. This figure represents the experimental design. The table summarizes the environmental condition to which the fish were exposed. The fish were exposed in 24 hours light photo period during the entire trial. After an adaptation period, the fish were randomly distributed in 3 treatments based on light irradiance. So we have low irradiance group, medium irradiance group, and a high irradiance group. The irradiance levels were chosen based on the minimum light detectable by fish and the irradiance levels we observed in the field during light measurements. This trial lasted until the fish weighed around 3.5 kilos. The irradiance levels were monitored by the Bioled automation system. The fish were monitored by ultrasound, tagged with peak tag, and weighed at different sampling points. And currently we have the results until the 3rd sampling point. This figure shows the female maturation or gonad development of females with ultrasound. G0 means immature females. In G1 and G2, you can see the gonadal development becomes evident. In G3, you can see a field decoloration, and G4 represents fully mature female. So the baseline, regarding the baseline data, at the beginning, all groups had the same weight, around 950 grams. But in the first ultrasound, we detected early maturation. The red square represents the G3 and G4 females in each group. So we decided to remove those fish in order, because we thought that maybe they could have affected the subsequent results. Regarding the data to the 3rd sampling point, or the results, in terms of growth, we don't see any difference in the terminal coefficient. We see a tendency of a lower weight in the low irradiance group, represented by the gray line, almost similar to the condition factor that was lower in the low irradiance group. In the 1st sampling point, with ultrasound, we detect almost the 10% of fish in G3 and G4 in the high irradiance group, in contrast to medium and low irradiance group that we detected low percentages of G3 and G4 females. In the 2nd sampling point, we detect 20% of fish in G3 and G4 in the high irradiance group. A medium and low irradiance group showed a less maturation percentages compared with high irradiance group. But in the 3rd sampling point, the trends shift slightly because we observe G3 and G4 percentages almost similar to, in medium irradiance group, similar to the high irradiance group. And lower G3 and G4 were observed in the low irradiance group. This graph represents the gonadal development evolution into the 3 groups. Initially, all groups had mostly immature females, represented by these blue bars. But in the 3rd sampling point, we observed no immature females in the 3 groups. Another interesting thing that we observed that fully mature female, that is G4, and represented by the purple bar, was higher in the high irradiance group. This graph represents the maturation, cumulative maturation in the 3 groups, and we see clearly that high irradiance group, represented by green line, is higher compared with the medium and low irradiance group. Also, we established a maturation coefficient based on how quickly the transition occurred from one maturation stage to the next. So, for example, if the female in the 1st sampling point is in G0, and in the 2nd sampling point is in G1, the maturation coefficient is 1. In this another case, if the female is in G1 in the first sampling point and moves to G4 in the second sampling point, the maturation coefficient is 3. In the tables below, we observe that high irradiance group, the 11% of fish move quickly from G0 to G4. It means rapid maturation. So the fish in the high irradiance group mature earlier and faster. This behavior was represented in this graph. When we can see in the green line that high irradiance group accelerates the maturation development compared with medium and low. Finally, when we match the maturation coefficient with the weight percentile, we can see here that high irradiance group, it is higher, the green line, especially at low weight percentiles. But this difference becomes less pronounced as the weight percentiles increases. But in medium and low irradiance group, the maturation coefficient is lower and remains stable at different weight percentiles. So in summary, the main highlight of this study are irradiance is as important as photoperiod regime in controlling early sexual maturation. The data suggests the higher level of irradiance accelerate and increase the proportion of female maturation. A medium and low irradiance range appears to be the best at controlling early maturation. So we are waiting for the last sampling point to have the full view of this study. So in that case, we're going to see the main result of this study. And finally, I would like to say thanks to the IMED group, IMED team. Without their value support, this study couldn't be possible. And of course, the R&D department of the Bioled. Thanks for your attention.
Yes, thank you for the nice presentation. We have time open for our short question. Are there any questions from the audience? Yeah. Okay. Yes, just one short question. Since you are using 24 hours time regime, do you think about to test other time regime in your
Yes, of course. That is the second part of the study. Okay. Because we know that maybe 24 hours is not the best if you have high irradiance or medium irradiance in RAS system. Yeah. In CKH, it's not in the farm system. In CKH, it's not an issue. But we are promote to the clients to use other photoperiod regimes, 24 or maybe decrease. There is a study when decreased photoperiod regime reduce early maturation compared with 24 hours light constantly. So yeah, we are, the second part of this study is to test different photoperiod regimes, of course.
Yes, thank you.